All right. Hey, everyone. My name's Jen Villa. I'm a director of product here at Grafana Labs, focused on our databases. So if you love Loki, Mimir, Tempo, Pyroscope, come talk to me. Find me at the experts booth after this. A little bit about myself. I grew up in sunny Miami, Florida, which means I find myself doing a lot of things outdoors, although currently I live in Austin, Texas. I've picked up pickleball, me and the rest of the United States, it appears. For my talk today, what are we going to go over? First, a little bit of framing the problem. Why talk about cost management for observability at all? Then how we as a company are thinking about this topic. I know Richie already talked about it a little bit in his keynote, but I'm going to go into a little more depth. Then we're going to talk about how we're approaching cost management for metrics, followed by how we're thinking about this for logs. And lastly, wrap it up with a little bit of what's next. Where is it that we're going over the coming months? First graphic here to kind of frame this conversation. We see that the adoption of observability is happening faster than ever. This is a graphic taken from the CNCF yearly survey where they ask folks, which of these technologies are you using in your cloud environments, right? And we see that open source monitoring has massive adoption and is continuing to show growth in adoption, right? Now, as an observability company, we love this, right? But we believe in the value of observability, how it allows you to grow your software systems effectively, efficiently, make your software development teams more effective, and leads to fewer outages, faster time to detect, and resolve. Now, there can be, though, some unexpected downsides to the rise in adoption of observability, right? Because it turns out that your spend on observability tends to roughly correlate with the amount of data and telemetry that you're creating. This is true both if you're running it yourself in open source, right? The number of machines, the resources required is going to go up, or if you're using a vendor, right? Most of them are going to be charging you based on a function of that data that you are creating and storing with them. We saw this same trend in the observability survey that we ourselves run, where 73% of our respondents cited concerns about cost and cost-related issue as the top thing that worries them as they're trying to roll out observability at their companies, right? And it makes sense. You're trying to bring a lot more teams, more and more teams onto your observability platform of choice. Many of those teams may not know much about observability, or you're busy kind of teaching them best practices. And so it's unsurprising that there is occasionally going to be significant spikes, right, as folks are still learning, trying to understand, how do I actually implement this? Now, what we don't want is for folks to get burned by a really bad month where their cost goes through the roof and then suddenly give up on observability, right? It's important to us that the adoption of observability feels sustainable. And it's interesting that we saw kind of a similar trend with the initial move to cloud, right? So there was time, and it's still probably happening. Many of you are at different stages in a journey of moving to cloud, where it felt like everyone was doing this. And as this was happening, right, with this kind of like stampede of we're all moving to AWS, GCP, Azure, right, a bunch of people then saw inevitable cost overruns, right? All these machines I provisioned that I forgot to clean up, that I didn't think about. And this, therefore, led certain people to say, hey, is the juice worth the squeeze? Am I really getting all these like mythical benefits out of going to the cloud that were promised to me in some white paper that I read? Fortunately, I would say, like, to their credit, the cloud providers responded to this. And they've built a fair bit of tooling into their product to help you understand how you're using the resources. Now, some of you may have different opinions on how good or not that tooling is, but it is there, right? So they've realized that it's important that they give you some visibility into what is and isn't being used, how that cost is broken down. And so what I would say is that we ourselves are doing the same for observability. We want to help you understand where that usage is coming from, so you can optimize it so that as you all adopt observability, it feels like it's happening in a sustainable way, in a way that what you're paying for is aligned with the value that you're getting out of it. Obviously, if it costs you more to monitor your application than that application is contributing in revenue to the business, that's probably not a very good trade, right? We started this journey to bring more observability to the cost, the spend that you have on our platform, with our cardinality management dashboards. These have probably been around now for about a year and a half, 2 years. They surface the highest cardinality metrics in your Grafana Cloud metrics account, as well as the highest cardinality labels. This can be particularly useful when you suddenly see a sudden jump in the amount of time series you're sending to us, and you're trying to figure out where did that come from. Oftentimes, the top cardinality labels will help you find some very interesting things, such as how come someone is making error message a label on my time series. We built on top of the cardinality management dashboards, and we added another feature known as usage groups. This is going to let you count the number of time series over time associated with a particular label key value. So if you want to count how many time series are associated with product equals Jen's amazing product, you can track that over time. You could even choose to alert on it in case that count of time series exceeds what your expectation would be. And probably our flashiest and most exciting feature in this sphere of cost management, we built this great feature called adaptive metrics. And I'll be using kind of the latter bits of my talk to go in a bit more depth here. This is one I could probably talk about for days. It has made me certainly lose days of sleep during its development. So far, though, what you see is that we have provided a lot of tools around cost management. Now, unfortunately, it's kind of been up to you to hunt for the right one, though, which can get in the way of you taking advantage of them, because you have to click around in our UI, find the right documentation page, and figure out, all right, for what I'm trying to do today as relates to managing my bill, what should I be using? So we realized we needed to do a bit more organization of these tools, of this feature set, to make it more accessible to you. And so to do that, we thought about, okay, what are kind of the classic jobs that you all are doing as you're thinking about managing your costs? And we thought about it for ourselves as well, right? We look at how much we internally spend on observability for Grafana Cloud. And we kind of bucketed into 4 common use cases or pillars, right? The first being inspection. I want to know, where I stand today with my usage, what's going on with my overall bill. Second is attribution, or cost segmentation. Which teams, which groups within my company, which products within my company are responsible for which fractions of my usage. 3 is optimize. All right, now I have a sense of where my usage is coming from. How do I figure out which pieces of it I could trim down? And the last piece is monitor. Right? How do I proactively set some alerts or kind of follow along with this so that I don't have these unexpected spikes or overruns in the future, or at least I'm made aware when they're happening. And so using that kind of philosophy of how we would organize cost management features and the jobs that you all are trying to get done, we have brought all of our cost management features together into what we're calling the Cost Management Hub in Grafana Cloud. So this is live in all your environments, and you can take a look at it. It's under the administration menu, and it's going to bring together the various pieces of Grafana Cloud that help you understand and look at your spend. Now, I'm going to spend a little bit of time here talking about adaptive metrics, which is my favorite tool in the cost management tool set. It's a tool that's going to fall into that bucket of optimize. Right? I want to reduce the current spend that I have today. How do I do that? In kind of a pre-adaptive metrics world, we had a lot of customer conversations where customers would say, hey, right now, I'm spending more than my organization has in its budget. I'm just going to randomly drop metrics because I don't know which of these are useful, but I still need to get my spend within some amount. What we did with adaptive metrics is we moved beyond that. You're not just randomly dropping things without any understanding of where they're being used, how they might be useful to you, but rather we're going to guide you and help you understand of the time series data you have, what's the low-hanging fruit that you could remove and still actually be able to observe your applications, right? The extreme way to reduce your observability bill is to stop creating or collecting any time series data. We don't want that because if you do that, you will have then no capability to observe your applications. So how do you find that right balance between here's the time series data I need and here's what I'm actually willing to pay for? Now, quick overview on how adaptive metrics works. It's really two services. So one is a recommendations engine. It's going to have these three parts to it. And the other piece is an aggregation engine, which when you decide, hey, these are the recommendations I would like to accept, it's going to actually execute those and aggregate your time series data. We're really excited about the recommendations piece. We think that's probably the most unique piece of this feature. At a high level, what it's going to do is it's going to analyze the time series data that you're sending to Grafana Cloud, looking at what we're receiving. And then it's going to compare that to your actual usage patterns. What dashboards have you created in your environment? What queries have you run in the Explorer over the last 30 days? And what recording and alerting rules do you have in place? And by comparing what you're sending us to what you're actually using, it's then going to come up with a set of recommendations. Because what we see is that there's a number of metrics that never get queried in any capacity at all. And then there's also a number of metrics that are queried in very specific ways, such that a certain set of the labels are used, but other labels are never used. And so what we can do then is say for those labels that really never get used or never needed to respond to your queries, we can aggregate those away. Now, I would like to show you, if the team back there can switch me over to my laptop, a little bit about what this looks like in our product. If it's not working, I can just go off the video, but yeah. All right, trying the old unplug, plug it back in strategy. All right, okay. So this is our demo instance of Grafana Cloud. Here, I've dropped us directly into the adaptive metrics plugin that we've built into Grafana. So I'm going to give you a little test drive and explain kind of some of the different features of it. The first thing you'll see here is a notification of when our last recommendations for adaptive metrics were generated. When we first launched this feature, we were generating recommendations every 24 hours. We've since shrunk that to be approximately every 1 hour. So we're really excited that we're a lot more responsive to changes in your usage patterns. You know, that means if you add a new dashboard, we'll pick up that that new dashboard showed up in our recommendations job within a couple hours. The next thing you see here is the time series reduction that you're getting from the feature today. So right now, with the applied aggregation rules I have, I'm reducing my time series count by 85,000. So that means I'm sending some number of metrics to Grafana Cloud. I'm storing some number. The difference between those is 85,000. We only charge you. You only pay for what you store. So your mental math could be multiply that 86,000 by approximately your cost per time series, and that's how much you're saving in dollars. We've got a little overview of how the feature works, but I'll jump right into this recommended rules tab. So here what you see are all the recommendations coming out of the recommendation service. And we can expand one of these, and you can see that we're recommending to aggregate this replica set metadata generation metric. Our recommended aggregation will reduce the time series associated with this metric by 94%. We are recommending aggregating away the replica set label. And we will aggregate over that label using count and sum functions. What we've detected here is this metric is actually not in use anywhere in your environment. So in this case, we're aggregating it to a smaller version of itself, giving you 94% savings, but we're actually keeping sort of a compressed version of this metric in case, maybe in the future someone might query this. Here's another example, this probe duration seconds bucket. This metric, we've seen it's actually been queried 61 times in the last 30 days. But we're still recommending that you can aggregate away these config version and instance labels because from what we've seen from analyzing those 61 queries, none of them depend on those two labels. Applying an aggregation is as simple as clicking a button, and then you'll actually see it showed up here in the Applied Rules tab. So these are the rules that you currently have in place. And so when you expand that, you can see here's the metric I'm currently aggregating, here's the functions I'm applying to it, here's the labels I'm aggregating away, and here's how I see it being used in your environment today. Should you decide, hey, I actually want this metric back in its kind of full high fidelity form, I want that label back that's being aggregated away, all you need to do is click on this Remove Rule button, and the metric will be disaggregated. Usually takes 3 to 5 minutes maybe to apply, and then you'll have the unaggregated version. All right. So a little bit about how this works under the hood. So I'll take you through an example here. So let's take this node CPU seconds total metric. So this is one metric, and there are 4 time series associated with it, right? We see 4 unique combinations of key value pairs created by 2 labels, mode and CPU. Now, let's say our recommendation service says, hey, I noticed that no one is querying this metric using the CPU label in any capacity, so I'm recommending that we aggregate away that label CPU, and we aggregate over it using a count function. How does this actually work in the aggregation engine? Well, we're going to essentially drop that label, group time series by matching label sets. So now we have a system group and a user group. And then we're going to apply our aggregation function. So a count to each of those groups. We have a count of 2 time series in each of those buckets. So the result of our aggregation in both cases is 2. So what do we do here? We started with 4 time series. And now we've reduced it by aggregating over the CPU label to 2 time series. It's a 50% reduction in the count of time series, 50% reduction then in what gets stored and what you pay for. Now, what does this look like on the Grafana Cloud backend? You can see in red, this is the time window at which the aggregation is actively being applied. What you'll notice at the top, this is the result of performing a PromQL count query. What's great is if you look at before and after the aggregation is applied, the result of that numerical operation is the same. The same thing happens if you look at applying the sum function, right? Before and after, the result is the same. And this highlights that we're actually aggregating the metric in such a way that the result looks the same. So if you're an end user, you're a developer, they just keep querying the metric, they keep seeing the same value they saw before and after it was aggregated. Now the panel, someone who is responsible for the observability bill cares most about is the bottom panel, which shows your billable time series. And you can see that after the aggregation is applied, that count of time series decreases. So users are seeing the same results for their queries. Your bill is seeing a lower number. I am happiest about adaptive metrics when people tell me I didn't even realize it was there or doing anything, right? And that's the dream, the goal of this feature. we're aggregating away things that weren't really being used. So in most cases, most people don't even know the difference or experience the difference between an aggregated or an unaggregated metric. We've since added some advanced use cases to adaptive metrics as we've seen more and more adoption of this feature, right? We have over 800 customers using it now, hundreds of millions of time series being aggregated. Some folks, they love our recommendations, but they actually say, hey, I would like to add additional aggregations beyond what you're recommending to me. I have some knowledge of my system. So you can do things now like define custom rules that match all metrics with a particular prefix or suffix. So for all metrics matching HTTP request total, please drop the instance label aggregated with a sum counter aggregation. Similarly, we also have keep label rules. So this allows you to say, for this metric, proxy SQL queries total, I want to specifically keep the namespace and job labels, but please aggregate away all other labels on that metric. Another great addition we've made to adaptive metrics recently is what we call exemptions. This has come up because we've had a lot of customers talk to us who said, hey, I love the recommendation service, but this metric, metric X, is extremely important to my business, and I never want it to be aggregated. I don't care if it's not in a dashboard. I don't care if no one's querying it. It must remain untouched. So you can build an exemption that says, hey, please never aggregate that metric. The same is true with labels. We found that many customers have certain labels that are important to them, sometimes for cost segmentation even. Hey, my product label or my business unit label or my team label, I want to make sure that that label never gets aggregated away. You can set up an exemption that says, hey, adaptive metrics never recommend aggregating away this label. For those of you who love as code, we recently added a Terraform provider for managing these aggregation rules. So you can both do so in the GUI, like I showed you, or you can use Terraform. And the last slide brings me to is what I'm most excited about. I think this was really in our initial vision for when we started building adaptive metrics, but we're only just getting there, is this idea of auto-applying the recommendations from the recommender system. So in the early days, the way this worked was adaptive metrics makes some recommendations, human in the loop reviews them and decides, hey, I want some of these, but maybe I'm not so sure about applying these other ones. As we ourselves and as more of our customers have built confidence with the recommendations, we are already actually seeing people who've scripted this. They pull down our recommendations and they just apply them daily. We now want to make that even easier for anyone using the feature. This will take out, really, the human in the loop need to daily interact with the recommendations. And this is made possible not only by the fact that we're running the recommendations job more frequently now, but also based on the fact that we have extended the recommendations job to not only recommend aggregating metrics, but disaggregating them in response to changes in your usage patterns. So what this means is that if metrics X is aggregated, developer Jen comes along today and tries to query it for a label that might not be there anymore, the recommendation service will detect this. It will propose in its next run, actually, we should add that label back. We should stop aggregating it away. And then Jen, next time she comes along, will be able to complete her query. And so this is going to bring us to a world where we're basically dynamically aggregating and disaggregating your metrics in response to how you all are using the system, which means that at any given time, we are storing exactly the metric set that really maps to the usage you have, and really trying to find that sweet spot between how much you're paying and the value you're getting out of the system. So stay tuned for this one. We are starting to test it with a small handful of customers. If you're interested in this, let me know. All right, with my last 5 minutes, I want to touch a little bit on logging, right? I've said a lot about metrics. We started with metrics because that's where we were hearing the most pain. Also because, fortunately for Loki was really good at storing a lot of logs very cheaply. But we get it. At some point, log volumes get extremely large, and no matter how cheap your unit cost is, when you multiply it by petabytes, that's still a big number. Similarly, we also see more and more companies putting their costs under the microscope, and nothing is exempted from that kind of a review. So we've launched our first cost management feature in the log space, known as the Log Volume Explorer. And this is, I call this almost more like the cardinality management dashboards for logs. It's going to help you analyze and understand where your log volumes are coming from. And I'm going to show you really quickly how that works. So if we could switch over to the computer. So here I am in the Log Volume Explorer. We start with a little video about how this feature works, but I'm just going to jump into the feature itself. So oftentimes what we see is that our customers know what particular labels they like to segment their log volume by. So for us in Grafana Labs, for example, we rely a lot on the namespace label. We're a very Kubernetes-centric shop. And so one of the first things I might want to do is break down my log volume by namespace. What I see when doing this is, all right, there's about 33 gigabytes of log volume associated with the production namespace, and 1.8 gigabytes of log volume associated with the dev namespace. I can do that over an arbitrary time range. I have 1 hour now. Maybe I want to do that over 30 days. Boom. Let's say I want to break that down further. I can do kind of the next level of segmentation. So maybe I want to look at the development namespace, but then I want to break it down by job. Great. Now I can do that as well. Let's see how it worked over 30 days. Nothing like a good old live demo. How am I doing on time? I'll show you over the last hour. Let's see. There we go. One other nice thing that we have, in addition to showing you the total volume, so if you look at the total volume over the last hour, is the ability to then look at that ingestion rate over time. We find this to be very helpful. I'll show it to you here. We find this to be very helpful because you can see when there's spikes in log volume. So if you look here, the production namespace was pretty quiet up until around 11:15, where we saw a jump in volume. This is helpful when you're looking at your bill for the month. You're like, how did I get to 50 terabytes? Did something change, or was it steady state? Now you can actually see where the peaks and valleys were. So switching between these kind of two views, what is the aggregate volume ingested versus at an instantaneous moment in time? What was the rate of ingestion is really going to help you work back and figure out, all right, what is the chattiest part of my logging infrastructure? Which is then going to help you start figuring out, OK, then how can I start to optimize the log spend that I have? All right, and we're not done there, right? The Log Volume Explorer, it helps you understand where your log volume is coming from, but it's still then kind of on you to figure out, all right, I've got to go back and bug my developers to remove some lines from their code. We want to do better than that. And in the same way that we introduced adaptive metrics for helping you reduce your time series volume for metrics, we're actively working on developing adaptive logs using that same philosophy. We want to calculate a difference between what you're sending us and what we see you actually querying, and use that to create recommendations about what you should be sampling or dropping or aggregating away. And we think this same philosophy will really help you be smart about what is it that I want to keep, what is it that I want to throw away, so that you can sort of maximize the value you get out of your observability budget. And with that, thank you very much. I appreciate the time.